to the last presentation for today. And our next speaker is Eric Tice. I hope also I pronounced the surname correct. Eric is the Global Director of Technological Consulting and lead for the Wipro Open Source Program Office. He provides strategic consulting services and leads the OSPO SMEs to assist clients with the strategic planning, transformation, and the development of custom solutions using open source technologies. Eric has a rich experience of over 20 years in the IT industry and has played varied roles such as that of developer, solution architects, enterprise architects, and manager. His interest is in open source and automation goes back to his developer days, and over the years he has gained considerable expertise in leveraging open source to deliver business value and drive business agility for customers. Eric is a thought leader in areas such as DevSecOps, observability, and open source government. Eric today will take us through a journey of several ops, as you see in his in the title of his talk. So Eric, please go ahead and share your screen, start your presentation. Thank you very much.
Okay, I have multiple monitors. So I want to make sure you're seeing the right screen. So are you seeing the
purple one?
The presentation mode?
Yes.
Okay, great. Thank you. Okay, so I appreciate the warm introduction. As stated, I work for Wipro Technologies. I am a director of our Center of Excellence and our technical consulting. Today, we'll talk a little bit about some of the variants and what are called the various ops. As many of you know, this is a fairly wide-ranging topic. And of course, we won't be able to cover all of them today, but we'll focus on some of the key ones that are leveraged in the industry and how they can potentially help your organization, as well as some recommendations and potentially ways to implement moving forward. Okay, just a quick note. As I mentioned, I work for Wipro. I won't stay on this for too long. As noted, I've got over, at this point, 25 years of experience. Most of my career has been touching open source in one way or another. DevOps, even before DevOps was technically a term, the agility of doing automation and other components when Agile first began are all things that I have as part of my experience. Wipro as an organization is a very large company that encompasses a lot of very skilled experts in this area. And we have a lot of partnerships that help us to solve problems and quickly deliver to our customers in the areas of DevOps and DevSecOps. So thinking a little bit about the evolution of where we were and where we are. So there's a lot of legacy applications over the years, building out COBOL and RPG and other systems over time. One of the things that all organizations started with is some degree of IT ops. IT ops being just strictly the reality of having to build out your infrastructure, create support, help desk, desktop systems and other components to help build and maintain your internal IT applications within the organization. And be this office type applications, client facing applications or others, this was typically a very manual process that still continues in many organizations today. At its core, all other ops, for the most part, leverage IT ops to some degree. This will be a continuous thing, but it is the basis for pretty much all modern ops at this point. Something to note is that realistically, by some of the current state of DevOps discussion points, only about 40% of polled companies say that they'll have a fully implemented DevOps capability or an advanced ops function by the end of 2023. Thinking about this as a fairly broad scope, and these numbers certainly change from one to the other, but thinking about just how small that really is in the grander scheme of things, we'll talk about what DevOps means in just a second. But over the years, at this point, over the last decade and beyond, Agile kind of came forward as a framework to start streamlining and improving development processes. As I mentioned in IT ops, a lot of the things were very manual. They were very strict process oriented. Oftentimes you'd find that an implementation of code or a new infrastructure could take hours or potentially an entire day to fully realize a new push out to the production system, where Agile was an attempt to try and solve some of those problems, to really streamline the process of development and delivery, to more rapidly push out code, but it didn't necessarily address the needs to do delivery enough. It did release requirements where it would be smaller snippets of code, but it wouldn't necessarily cover the problems of a distributed system and the processes that come with having to push code to, potentially hundreds or thousands of variant servers. Beyond that, Agile, there was the first kind of, not quite ops, but a first step toward more of a DevOps was CI/CD. And the reality of this was it took some of the same principles that Agile did, but applied them with tools where continuous integration, continuous delivery would look to improve this from a technology perspective, creating a pipeline of tools that would automate to some degree the ability to take code, run the tests, builds, and release them in a faster and more efficient way than doing it manually to reduce time and other components. Well, this covered a number of capabilities, but many organizations would implement this and still use it as a somewhat manual process, rather than setting up appropriate conversation points around how do we automate our builds more efficiently, how do we incorporate quality checks and other capabilities. And this has evolved over time, where many organizations have done a good job of starting to incorporate those tools, but it's still a tool set. It didn't fully manage the process issues or other capabilities that Agile tried to achieve. And as a simple solution, CI/CD just isn't necessarily good enough for most organizations as they continue to evolve, which brought forward kind of the term of DevOps, which essentially takes CI/CD and Agile principles and starts to merge them in a way to produce a more collaborative environment where there's some overlap in capabilities between development and ops. And one key consideration here that is overlooked by the name in and of itself, and we'll discuss this a little bit more in subsequent slides, is that it's not just development and ops, but it really starts to bring together the complete Agile team of QA and business analysts and others to be more cohesive in the approach to pushing out and providing appropriate application releases. So as we talk about those base kind of ops, we bring in some other ones like FinOps, which is a financial operations process-oriented type of ops that is used, as the name would suggest, primarily within financial institutions. This is something that is part of the Linux Foundation and the FinOS Foundation as well. It's a very interesting set of processes for the financial industry. Risk ops, which brings in more the cybersecurity discussion around what are the compliance and potential risk and threat analysis that can be done what are the processes around that and how you would potentially manage that. These two in particular, we won't spend a lot of time on today, but we'll talk peripherally about them. SecOps, which, as the name would potentially provide, is security and ops. So this brings together IT ops and security practices, which we will focus on the evolution of this quite a bit in subsequent slides. And then some of the more popular ones in the industry right now, like GitOps and AIOps and DevSecOps. We'll talk about what some of the variants of these are and how potentially they feed into your potential environments. But before we dig into the definitions and how they fit, some of the strategic drivers within the industry as to why people are considering automation, advanced DevOps, and these other ops processes are some of the advancements and innovations in the industry beyond taking on-prem based typical legacy deployments where you have most everything running within your data center in potentially large monolithic applications, or in some cases, even building them out to be more SOA or other, depending on languages, other architecture bases. Some of the key ones in the industry now is I'm sure you're all aware, which affect certainly the open source landscape quite a bit, our digital transformation, where the discussion around migrating from a legacy system to a much faster and more cost-efficient solution, which will essentially reduce your total cost of ownership, provide ways to improve scalability and faster time to market, also focuses on the cultural discussion of how you implement your focus. Under cloud migration, where this is since COVID, this is something that's skyrocketed in capabilities and features, where everyone, even if they were somewhat hybrid modeled to the cloud or still running primarily in data centers, we've seen a large increase in the number of cloud migration projects as more and more people work from home, and the infrastructure cost and need for resources to be able to be hands-on has started to migrate away because of the complexity and logistical costs necessary to do this. Cloud migration has continued to skyrocket. And of course, that doesn't negate the need for open source, as a lot of the potential services offered in cloud, such as AWS, Azure, and others, leverage open source under the covers, as it were. And then, of course, cloud native, which is primarily based in open source technologies with things like Docker, Kubernetes, and others, which take more of a cloud agnostic approach to being able to really develop, be it private or public cloud, to any environment. So thinking about the flexibility and the resilience in this case, which comes with a lot of the cloud native capabilities, really helps to discuss how am I going to build my system in a way that I can automate a lot of the migration components. I can scale and manage large cloud native clusters within Kubernetes or other orchestration technologies to make sure that I can be efficient for my teams. And of course, manual processes in this case would just be entirely incapable of doing this, as the sheer amount of resource, time, and effort to do so would be astronomical. So we mentioned DevOps as being one of the areas, and really the key component of DevOps, as I mentioned, is really development and operations coming together, but it's the collaborative environment of the best practices within DevOps, as well as the tool sets. So taking, again, CI/CD tools as a way of implementing and automating those capabilities, but taking those best practices that were essentially developed as part of Agile around speed of delivery and improved time to market, but also looking really at ways as you automate to start looking at greater stability and scalability in the industry. Now, a key component of this that, again, a lot of people don't think about is that DevOps realistically is also beyond the technology. It's very much an incorporation of ways of working within the teams themselves, starting to bring together a number of stakeholders and interact more collaboratively over the SDLC process to assure that you can achieve the business goals more effectively. Now, one of the ways that DevOps is often implemented is it's thought of very specifically as just a CI/CD implementation, which, that's how most organizations tend to implement DevOps currently. Is it's if they believe if they have a CI/CD pipeline, say as Jenkins, for example, that will allow them to automate some capabilities, that they're fully implementing DevOps. Where DevOps is not really just a tool set, it's also a culture. So in this context, we really think about DevOps as an integration of agile principles or lean principles and DevOps practices, where essentially it brings together all of the various different types of components that you would hope to achieve, where it focuses more on people and collaborative team environment to break down the potential silos that exist within an organization. So typically many organizations have had issues with having to develop new and innovative ways of working, because the process around implementing code, sharing the code, testing the code, and delivering the code is all broken down into separate groups with very much a this is ours and that's yours responsibility matrix that didn't allow for a lot of overlap, which caused a lot of inefficiencies and essentially having to throw the code back over the wall if there were test issues, if there were long issues with deployments, or the deployment would fail due to a lack of cohesion or understanding as to what all the configuration files that were necessary, and a myriad of other problems, where this cultural change really starts to look more toward enabling the business through technology and having the cohesive teams from the process initially around ideation all the way to delivery, working very closely together. Now, one thing it does continue to obviously do is really try to build in automation at all stages. As you can see, agile development, which would bring the product stage through the development stage, integration, testing, delivery, all of these components would continue to look to be automated in a system to help improve time to market as well as efficiency of the resource base. So DevOps, while isn't a new thing, is often implemented incorrectly by a lot of organizations because they tend to look at it just as a tool or a set of CI/CD tools rather than a holistic cultural change within the organization. And of course, through this collaboration and the ability to incorporate testing, integration practices, and other things like observability, you can increase the amount of insights that you have into the technology, as well as the processes, to better plan and scale. So this is something DevOps does at a very high level. But again, unfortunately, a lot of organizations either still aren't implementing this or may not be fully implementing it to its greatest potential. So another big one that's gained a lot of traction in the industry lately is GitOps. Now, if you're familiar, obviously, with DevOps, the question is how are they different? Well, the reality is that GitOps is not really in and of itself an ops discipline. It's an operating model that really sits on top of DevOps, leveraging Git. Most organizations today, and this is a fairly reasonable set, is leverage Git in some way or another, whether they use different tools like GitHub, GitLab, Bitbucket, or any variants of Git. It is the most popular repository existing today. And utilizing tools like GitHub or GitLab, they've incorporated a number of CI/CD components within their tool structures, but still most of that is open source and technology based. And what GitOps is trying to achieve for your organization is really to streamline some of the tooling processes and around how you develop a strong DevOps. One of the key components that can be very daunting within building out the CI/CD portion of DevOps is the sheer number of tools that typically get added to a pipeline. So thinking a little bit about that, as you have a repository for your base code, you may have a package repository, a container repository, and others as you build out a cloud native environment, where essentially GitOps tends to really look to provide a single source for all of your application, infra, and other capable codes. If you're doing infrastructure as code, for example, into one repository base, and allowing you to really automate or focus on automation rather than focusing on having to maintain a large tool set. It also provides a capability around storing and managing data more efficiently in a single platform. And if you leverage a more advanced form of GitHub or GitOps, you can leverage things like GitHub Actions and workflows and other capabilities completely all from an enterprise Git, or even from primarily just the open source Git platform will provide a number of these features. But in more recent years, certainly GitHub and GitLab CI, for example, have evolved to provide a fairly advanced set of components to support a cloud native environment and the delivery of more distributed and complex systems. So in this context, GitOps is something that is not holistically an either or scenario. You can certainly run a DevOps implementation and choose to use an operating model that allows for the tools around Git that will essentially turn it more into a GitOps implementation, but they're not mutually exclusive. You can't really run GitOps without DevOps. So from this perspective, there isn't really a huge difference other than the tool sets and the operating model of how you leverage them within your DevOps component. So I want to breaking a little bit from the ops definitions and thinking a little bit about the reality of the world we live in right now. Over the last decade, certainly there's been a continued increase in cybersecurity attacks. Well, the reality is over the last 2 years, either because hackers decided to become more active during the COVID times, and the unfortunate reality is that COVID being a very severe pandemic virus, it's affected so many of our lives. Unfortunately, that's not the only virus that we're having to deal with. Many hackers have taken this time to really start to increase the sheer number of attacks and threats that have been posed on organizations over the last several years. And over the last 2 years alone, in 2020, had seen a 430% rise in attacks. And just in this last year, in 2021, there was a rise of over 650% new threats that were looked at and found within the open source range. Something to note here about these statistics is that 98% of all applications, be they proprietary or open source, specifically leverage open source in some way. So thinking about the threat in the open source realm is it's not strictly an open source problem. It essentially affects all of the code that exists in the industry, which is quite scary, to be honest. But the reality is that software supply chain security really tries to mitigate these risks. It takes an approach to try and look at what the potential compliance capabilities are, where the potential threats lie within your infrastructure, your code base, configurations, and other capabilities, and find those key areas, identify them, and look for ways to improve the system, pardon me, over time, which is, of course, one of the largest moves in the industry right now. So as we talk about this, all of us by now are very familiar with the Log4j issues that came out in November of last year. They were initially identified, and then in December, it became a mainstream conversation where any application using Java, for the most part, and certainly there are some that don't, but the majority had been using Log4j under the covers as a means of managing the logging of their application data as just a core component from Apache. And there are certainly others that exist. But between this and then in the 2020, the SolarWinds attacks and a number of others in between, this has really become front and center. In the United States itself, the president had created an executive order about increasing supply chain security through enhanced cybersecurity. And there are a number of initiatives now in the open source realm, like OpenSSF and other components that are seeking to address this. And of course, we could have a complete different conversation on software supply chain security alone, but it does affect how we implement ops generally within the industry as well. So as an organization thinks beyond DevOps and what it provides the system, the conversation really becomes, what is SecOps? So while DevOps is developers and operations, and of course, as I mentioned, it doesn't stop there, but one of the key things that traditional DevOps doesn't consider is security, where SecOps, which has been around for quite some time, is really that merging of traditional IT ops with security practices. Now, this had been something early on in its beginnings was more leveraged by more compliance-based organizations, things like healthcare, government, medical, healthcare and medical, same banking and financial institutions, because there are a number of very strict compliance regulations that were needed, and things like SOX and PCI and other components had come out to help manage some of these capable feature functionalities, but pardon me. But the reality is that, in the broader scheme of things, SecOps was ignored in favor of CSO policies, where typically a CSO would manage the capabilities and the security group would manage the security policies around how often vulnerability checks might be done and penetration tests. And in many organizations, this would be something that would be looked at, maybe every half year or once a year to determine the safety of the system. And this was meant really to leverage key security practices as they existed at the time to really kind of make an effort to proactively manage security. But realistically, many of the SecOps capabilities were done in more of a reactive policy management phase. But in more traditional SecOps these days, shift left on security has been a key focus. And of course, really starting to integrate security into ops practices. So if you have an operations group rather than more of a DevOps collaborative team, ops groups try to do things to check security and manage the policies prior to deployment, which again is helpful. It helps to mitigate some of the issues, but it's less effective because it isn't throughout the entire SDLC process typically. Now, starting to bring some of that together, the reality is, we talk about DevSecOps. Well, of course, as the names kind of suggest, it's a merging of DevOps and SecOps. These days, as I mentioned, with the improvements and the necessity of software supply chain security across the SDLC, this is often termed as either SecDevOps or DevSecOps, just depending on what the organization's focus is. And typically more and more, the focus has been on security. So that increased SDLC security really talks about the automation of CI/CD and how you can implement, automation of security scanning, various types of security scanning, new processes and capabilities from day one, really starting to look at more of a developer-focused approach to security rather than more of a reactive ops-based approach to security. Too often, the reality of how SecOps or just in general security processes have been implemented in an industry had led to that reactive, once it's in production or once it's been released mentality, rather than thinking about security from day one when the code is developed, where DevSecOps really starts to think about that as soon as the code is going to be checked in, we start to think about how we're going to manage security. So thinking about the complete proactive pipeline of things like configuration scanning, vulnerability scanning, has the code been signed? All of these things are what are built into the sec part of DevSecOps to assure security of the code prior to release to any environment, and setting mitigation tasks within the pipeline to assure that these things are addressed as early and often as humanly possible, making sure that we can provide the most secure, capable function. Where this really becomes a key discussion point is that as you build out your applications and think about the vulnerabilities early on in these phases, you really start to think about the components in DevSecOps of how am I going to manage this? So from a vulnerability scanning perspective, there are a myriad of tools out there, both open source and more commercial based, that provide the capability of doing this. But what does that mean specifically, and at what phase of my pipeline am I going to address this? So a key component here is if I'm leveraging open source technologies, which as I stated earlier, everyone is, how am I managing the potential risk if I'm using a proprietary tool that may have, hundreds, if not thousands of packages that are open source under the covers? And you can do that in a number of ways. We'll talk about some best practices about that in a few slides, but really starting to think holistically about how am I going to manage not only my internal code base and the usage of open source technologies, but also the reality of how am I checking that? What are the bill of materials for my application, or more specifically for the proprietary applications that I'm using? As I mentioned, the very recent Log4j threat, how many of the potential applications that I've purchased or bought off the shelf leverage that technology, and how are they mitigating that risk so that my organization is not at threat? So these are key components that DevSecOps starts to try and address quite a bit more. So thinking about the ecosystem and open source, a little bit about DevSecOps, it's really quite broad, and there's some of you, if not all of you, have seen the DevOps periodic table, which encompasses a lot of the DevSecOps features, although it's a fairly light in the security aspects. Here are a number of potential broken down capabilities in open source that are used in a DevSecOps kind of component. And certainly this is not holistic. There are literally hundreds, if not thousands, of other tools that you can use in this area, but these are some of the more popular ones in the industry right now in areas like container management, security, artifact repositories, and others. But as you see, it brings together all of the SDLC components like source control, infra as code, monitoring, which is often one of the things, and this is certainly not a presentation on observability, but the reality of many organizations as they build out their DevOps, their GitOps, their DevSecOps, any of these approaches, is that they think of monitoring as more of a production environment need, where once the code is out where the client can see it is when it really needs to be monitored. And the reality is that setting observability monitoring capabilities across your SDLC and of course your DevSecOps processes helps you to gain insights not only into the efficiency of your infrastructure, but also of the processes and efficiency of your resources to help better scale and manage how you're able to get through the SDLC, where your potential bottlenecks are, what potential security risks and how often you're finding them, may spark a number of potential new processes and cultural changes to help address some of these issues and make things more efficient for your organization. And certainly, as I mentioned, this is a subset of information, and there's another presentation that I provided that's more on software supply chain security that actually extends the DevOps periodic table to incorporate a very large set of open source security components as well that aren't listed here. But things like FOSSology, which is an open source vulnerability scanning tool, tools like Whisper and Blue Bracket for configuration scanning, are things in the industry that are really starting to help implement DevSecOps quite a bit more efficiently than in the past, where vulnerability scanning was one of the key focuses rather than strictly end-to-end security. So we come to some of the last notes around different ops. As I mentioned, there are a myriad of others like risk and FinOps and others, but that focuses on a very specific set of tasks. And if we were having a cybersecurity discussion, risk ops would be one of the largest ones that we discuss. But realistically in the industry, AI is another key component that many organizations are really trying to implement in broader scope, starting to think a lot more about the metrics and KPIs that exist within their reporting structures and how that can better help their business to focus moving forward. And really, where we have DevSecOps, which is really the culmination of all of the evolution to automate, bring the teams together, provide a secure way to build and deploy your code around a culture of adoption of security practices and really focusing more on the developer rather than the operations staff. AI ops takes this in a completely advanced set of capabilities, which actually enhance any of the other ops functions. As I mentioned, observability being one of the key focus areas and monitoring being a key focus area of things that people should be looking to adopt early on in the process. AI ops takes that to another level beyond just key monitoring capabilities and really starts to incorporate things like the keys of artificial intelligence, machine learning, focus to really pull in the data and start to manage the data in a way that helps you to better plan and scale not only your infra, but everything across the board where, the infra is important because once you can determine where the issues are, you can more predictively do things like auto remediation or auto scaling of capabilities. And certainly some cloud environments provide AI capabilities and capabilities around business analytics. But they can be limited in some ways where open source provides some of these functions and capabilities in a continuously innovative way. So as you start to develop out your thoughts around AI ops, the conversation again about observability helps you really to build things like predictive analytics and anomaly detection to start to plan and understand, where are some of the potential anomalies that exist in the system? How can you react more quickly to them? APMs and other tools that exist within the monitoring space, application performance monitoring for debugging and managing other components are good, but it doesn't really necessarily help to provide long-term root cause analysis. Where is the potential issue? Is it a resource? Is it specifically the infrastructure? Is it the code base we're using? Is it a combination of several of these factors? And that's where providing this collection of data and really starting to manage pardon me, the scope over time will really help you to build better solutions, but it'll also help your executives start to understand just exactly how they're scaling their resources and their business development plan to leverage this technology more effectively. Do I need more resources? Is the infrastructure cost going to increase? Are we spending too much on infrastructure costs? And then a myriad of other potential components are things that AI ops provides. And again, as you look at the imagery to the right of the slide, this really takes the DevOps never-ending wheel and incorporates, the mind and thinking components of AI and machine learning to really enhance it to a level where, as you build this out, especially in the security components, the threat detections and being able to use AI and machine learning to really understand where and when those potential threats may raise themselves will enhance your application to the greatest level possible. I see there's something in the chat, but we'll come to questions here in just a moment. So we've talked a lot about a number of different ops components, be it the initial IT ops, be it some of the frameworks and other components around Agile, CI/CD, and how DevOps and SecOps led to a myriad of other potential operations. And we think about how we can potentially bring all this together, where this would be a potential CI/CD pipeline kind of viewpoint of all of the actions that may exist and a number of the potential tools that you might leverage to accomplish this. So kind of thinking about one approach to how you might bring together a complete ops solution and certainly the recommendation based on this would be something of an AI DevSecOps type of approach, where you would have, pardon me, a number of processes. You'll see the red box around this, which leverages something that we're very interested in called the SALSA framework. And the SALSA framework was created by Google and is a key talking point of OpenSSF's working groups to really start to enhance how you can leverage security at all phases of the SDLC. But as you think about your ops platform and the processes around it, the automation of CI/CD components across the board is the key first aspect, where leveraging security at each phase from the moment a pull request is initially submitted all the way through to when it's deployed is the key focus of the SecOps capabilities. And as you'll see, there's a number of tools in here like FOSS, White Source, Black Duck, which certainly Black Duck and White Source and SNCC are some of the popular ones in the industry, where SNCC and Fossology have more open source capabilities than a number of their counterparts. And then tools like Blue Bracket, which is fairly new in the industry and actually is incorporated with SNCC into LFX security. If you're currently part of the Linux Foundation, or it's something that you look at, you can certainly look at LFX Insights and LFX Security to see some of these components in action. But you certainly can see in here where tools like SigStore for code signing, which is an open source initiative that was built out of OpenSSF. So all of these security components across the board, and then leveraging observability and AI machine learning, apologize for the typo there, across your entire SDLC will only enhance this further, allowing you those key component insights to understand where am I failing more often than not. For example, if Blue Bracket is finding that your development resources continuously put AWS keys directly into a configuration file that everyone can see, well, that's potentially a security risk. So that, if that continues to happen, then it's certainly a training and resource problem. And there are a myriad of other things that you can certainly do. It'll see how often those things are happening, build an anomaly, and how often are potentially security threats. Are we using packages or dependencies that continuously show as being out of date, or pardon me, or are security threats to our system, and how we can improve those processes. And then of course, alerting and using ticketing systems to help manage this more proactively, to let the stakeholders know when these are happening, will help you define this more clearly. One of the key components here to mention is that this brings together AI ops and DevSecOps as one cohesive type of monitor. And of course, this is a very simplistic diagram leveraging, the concept of CI/CD and other very tools focused here and less process focused. And we'll have a couple best practice and recommendations in the next couple of slides. But there's something that's, more of a theoretical discussion in the industry right now, and that's the move toward an eventual no ops type of feature. I haven't covered that here because it is very theoretical. The premise is really that eventually you'll come to a point where you won't really need an operations resource to manage any of your ops procedures. They'll be fully automated and self-remediating, allow for complete autonomy and ability to scale and manage your systems in a way that the resource won't necessarily be a proactive part in that. And realistically, this will require a lot of AI features that aren't quite developed yet to be able to predictively manage that. We can get partially there with automation with a number of components, especially in cloud native and cloud environments with auto scaling and other capabilities from an infra perspective. But certainly when it comes to security and other capabilities, those are things that will take quite a long time before we fully trust an automated system to manage. So,
Eric?
Yes.
Maybe you have 3 more minutes left for questions.
Yeah.
Wrap up?
That's fine. I'll just wrap up
Thank you.
and just real quick, we'll answer these questions. So, just as I mentioned, there are a number of best practices and most of them are around security. I mentioned the majority of them already. But the key recommendations really, again, are to merge AI and DevSecOps into your solution. If you choose to use Git tooling to incorporate this using GitOps, you can leverage all of these together, or you can use a subset. But again, to really make everything work very well is really to merge your developers, your ops teams, your CSO security teams, if you have them all into one group of overlapping responsibilities to really manage your ops more effectively. So in the interest of time, there's a few questions. So users of open source rely on that community to resolve any vulnerabilities, but if the community isn't attentive or has lost interest, we might be stuck. So what are your recommendations? Okay, well, that's a great question. So the first answer to this question is if you're using a technology in open source that no longer has an active community, you should no longer use that open source technology. You should look to replace it. So part of the governance reality of how you leverage open source, and this is with or without ops, the reality needs to be that if they're no longer maintaining the application, you have two choices. Within an organization or a broader enterprise, you have to make the determination how important this open source technology is to you. Is there an alternative? Or do I want to manage this myself? In the case of managing it yourself, then the security threats and vulnerabilities would then be your organization or your enterprise's responsibility to maintain that over time. And then it becomes less open source because now you're making changes unless you're maintaining the community yourself. You've branched or forked it and potentially managing those vulnerabilities. So in this case, you have some choices to make. If the answer is it hasn't been updated in a year, and no one is touching it, that you're not able to get any of the contributors to respond to you, then it's time to make a choice as to whether or not your organization or enterprise chooses to take that on, in which case you should be doing vulnerability scans on the code regularly. There's a tool called Hygia out there that actually does this quite well. And it's not a holistic approach, but if you submit pull requests, it automatically does scans on all of the source code when that happens proactively. So one thing it isn't doing is a proactive timed scan to check the entire repository, which I highly recommend. But these are ways that you would manage this. You'll talk to the contributors and get them to buy into that. And then for SLAs on proprietary tools that use open source technologies, you have to ask them the question of what their SLAs are. How often are they doing these vulnerability scans on open source? And do they have anything that's currently deprecated? So I hope that answers that question. And then in the interest of time, for DevOps and other ops, where an organization should start, especially when it has in-house data center. Is migration to cloud inevitable? No, it's not inevitable. And you have to consider the reality of public versus private cloud. So if you're internal, you may be building an in-house private cloud, or it may just be more of a traditional VM data center type of environment where it's not required. And certainly no ops requires you to be in the cloud. I only mentioned that at the beginning because that's the trend that most organizations tend to be moving toward. But it doesn't mean that it's a requirement at any stage. As to where you start, well, you're traditionally already using some level of IT ops. Where you would start would really be to start digging into the core of the DevOps components and thinking about culturally how you interact between teams, thinking about the automation, if you have it, how often is it being done? What steps within your automation are actually automated? Is it just build and deploy? Are you integrating testing components? Do you have security components involved? And once you have a core design for your DevOps and you understand potentially the gaps or pain points in your process, you begin to develop out new ways of doing that, applying potentially agile or lean methodologies as well. But in parallel, you should be reviewing your security policies currently. What exactly are you doing? How often are you scanning and managing these things? And at the bare minimum, as I mentioned, because of the complexity and the sheer number of threats coming through and increasing all the time, looking to, as you build out your DevOps, to incorporate at a bare minimum vulnerability checks as something that you do proactively within your DevOps or your DevSecOps pipeline. So start at the beginning, look at, are you automating anything? How are you automating it? If you have, and this happens in some organizations, hundreds or thousands of variant applications, how disparate is that process across the enterprise? Are they all doing different things? Have you come up with a standard? How are the teams working together, and what tools are you leveraging? Make sure that those are the right ones, and certainly organizations like ours and can help to meet some of those needs and help you to understand those capabilities. But in this context, realistically, that's where you have to start. You have to understand where you are. An assessment and maturity discussion needs to happen so that you can adequately build out your DevOps starting point. And of course, my highest recommendation is not to do anything in automation without incorporating some level of security into your your DevSecOps capabilities. It's more and more crucial. And as you're aware from Log4j, these are things that we take for granted, that we've used for decades, that now all of a sudden are threats to our system. It really pushes for the need to do this at a very strict level. So I hope that answers your questions. Certainly, as we kind of ran out of time, I just want to show the last slide here. My contact information is at the bottom. Feel free to reach out to me via email or LinkedIn if you have additional questions post the presentation. I'll be happy to answer them. I hope you found this helpful, but if you certainly have questions or would like to dig deeper on any of these topics, please feel free to contact me.
Thank you very much, Eric, for this